Welcome to today's webinar. The topic today is Grasshopper and RFEM 6, news, tips and tricks. My name is Andreas Hörold. I am responsible for marketing and public relations in the company Dlubal Software. I will be the moderator today and I will answer your questions together with Paul. And Lukas will do the presentation, but my two colleagues can introduce themselves.
Yes, hello also from my side. My name is Lukas. I will present this webinar today, and I'm hired here as product engineer and customer support engineer, usually with the focus on the interfaces. Paul, your turn.
Hello, I'm Paul Sevorgin. I'm working student at Dlubal Software and support the product engineering in the area of interfaces. And today I'm also answering the question in the chat for you with Andreas.
Okay, thank you for your introduction. And we can switch off our webcams that the attendees can see the full screen. I say some words how you can ask questions for the attendees who participate the first time. You can show or hide the control panel on the right side of your screen with that arrow here, and then you can enter the question here in that field, and we will answer you. If you don't get an answer during the webinar because there are too many, you will get an email after the webinar. The other way is to watch the entire webinar and then email questions to info@dlubal.com. Okay, that's all from my side. I hand over the screen to Lukas and he can start with his presentation. Lukas, it's your turn. Yeah, I can see your screen. Fine.
Thank you. All right, thanks for the info. In previous webinars, I repeatedly shown examples in which I model a geometry in Grasshopper and then export it to RFEM via the plugin. However, our plugin has other functions that I would like to demonstrate today in short examples. It's not so much about modeling those examples live, it's more about describing the workflow. Let's take a look at the scheduled chapters of the webinar. I would like to start again with an update of the latest implementations since the last webinar in mid-February. Then I would like to show you that you can also use existing types in RFEM when you export from Grasshopper to RFEM. In chapter 3, I want to continue with the basic functionality of importing data from RFEM into Grasshopper, including the use of various filter options. Chapter 4 is the combination of chapter 2 and 3, showing the modification of existing RFEM structures. And in chapter 5, well, I called it first attempt of an automatic calculation loop using Galapagos. I will again mention this later, of course. All right, let's go into chapter 1. Wrong focus. Yeah, what are the new features that we implemented since the last webinar mid-February? A quite important one is we got rid of the dependency on the web service licenses. Yeah, you no longer need this license to use the Grasshopper interface or Rhino Grasshopper interface. We implemented new components for nodal releases and also a new component for imposed nodal deformations, both requested from our customers. Additionally, we created a new component for starting the calculation in RFEM 6. On top of that, also a new component for exporting the results from RFEM, obviously, to a CSV or XML file. I will mention those two add-ons later in chapter 5. And additionally, we extended the static analysis settings component with the number of iterations, the load increments, and the form finding iterations. Last two changes, we extended the surface component. You can now control the local access system as well as the integrated objects via the new inputs here. And we also extended the member component with a simple function, the member rotation via surface. These are the latest developments, and yeah, that's already chapter 1. Let's go into chapter 2, where I want to show you how you can use RFEM objects when exporting from Grasshopper to RFEM. So what we need now is, of course, Grasshopper and RFEM, which is this. So we have RFEM on the right-hand side and Grasshopper on the left-hand side. How do I want to show it? Well, I want to show you first, in really just 1 minute or so, again, how the usual workflow is. Yeah, usually you would model a certain geometry via Grasshopper components. With these Grasshopper components here, with this algorithm, I created this small stadium here. You may remember it from a previous webinar. The lines and surfaces from this algorithm will then be connected to our Dlubal components for members and also for surfaces. And in those components, we then can assign the member and surface properties. Yeah, thickness of the surface, the material, hinges, supports, and so on. To do so, we also need to create these information first. So we need to create the material. We need to create the sections for the members, also the thicknesses. And when we have all those information here, we can send it to the export and create the RFEM structure based on it. This is what I will do now. This is the workflow that I showed in my previous webinars. Actually, this was not what I meant to do. Small tip, in the past, you had to open an RFEM file when you wanted to export from Grasshopper to RFEM. Yeah, it had to be opened. This is no longer required. You only have to assign a name here. So if you assign a name of the file that you want to create, then it will be automatically opened, which I did now here. Yeah, this is a new input basically. And if I run it now, it should work. Did I? Yeah, just a second. Yeah, now it's creating the new file with the same name as I defined it here, and it will transfer the data. All right, the transfer is done, and I can see this stadium, including the section, materials, and so on. All right, so this was the general workflow, and now I want to show you how you can use existing objects in RFEM, for example, materials or sections or thicknesses, when modeling something in Grasshopper. What you can do is following. Well, or how I will just show it this way. I will get rid of the sections, the materials, and so on components. Yeah, I don't want to define it now. I will only use my member and surface components. So if I want to create a member in RFEM now, I have to link it to the Grasshopper line as I did it before. I can give it a name, doesn't matter in this case. And of course, I have to define the section for this member. Now, because I do not want to use the section component, I have to assign it differently. And I can do it by defining the index number of the section in RFEM. Yeah, I have here now a small number slider, and I can assign the index number that we have here in front to this input. So the main beam of my stadium should be cross-section index number 1, which is an IPE 600. And I will quickly do it for all the member components. Just a second. We will assign the right index numbers. For the columns, I want to use the same section. For different beams, section number 2, the IPE 140. Then I want to use also the IPE 400. For the cables, let's say this way, the section number 3, then this RB round bar 60. And for the coupling members in my roof, section number 4, actually 5. All right, same logic applies to my surface component. I have to assign a thickness here, and it should be the index number 1. So far regarding that, I think it's quite easy to understand. You simply have to assign the index number of the object that you have in RFEM. Now, regarding the export, we have to take care of something because we can no longer use the override function as true. Because if I override that now and I run the export, it will remove all these information and then write it again into this file. But then the index number is not connected to any object here. So this is not how it's working. So I have to set the override to false. And now we do not override, we add information to the existing structure in RFEM. Let me run the export. Yep, there we are. And wait. Yeah, okay. Now we have the same structure as before, yeah, all the cross sections, all the members and surfaces basically with the right cross sections. So this workflow is also working, yeah. I skipped the part of the definition of all these materials and sections and thicknesses in Grasshopper. What I have to be careful now about is that I can run this export only once in that way. I have 250 beams now, and if I would now run it again or modify it slightly and run it then again, I still cannot use the override function. I have to use this add, but if I add the same thing again, I will double the amount of objects that I have. So we can wait a second and then we can see the result. All right. Yeah, so we have, instead of 252, we have now 504 beams. So this means this add functionality only works once. Anyway, you can use it, and you can use it in a way that you, for example, that you maybe create the materials, the sections, all the objects that you want to have in your RFEM file once, then you save it in a template. And then you can create new files using this template, run the export as an add with the add functionality. And then if you want to change something, you simply create a new file again, load the template again, everything is defined, and you can again use the same Grasshopper algorithm that you already have. This is just an alternative workflow, or yeah, that I wanted to present here in chapter number 2. Now, I want to add something to that, and therefore I want to open the original file again. Yeah, where I define sections and everything, and I will remove the member components and also most of the section components. I will only use the material component. I get rid of the index number for now. And what I want to show now is that you can also modify existing objects in RFEM. How can you do it? Well, let's imagine we want to use a different material than the S235. Let's say it should be an S275. I have to switch it back to false, of course, otherwise I would remove everything and export just one material. But my goal is to modify the first material. Yeah? It should not be S235, it should be S275. If I run it like this without the index number, I will only export a new material. So this add functionality works in a way that when there is already something defined, it will create this new object on the end of the list, as we can see it here now. Again, this was not the goal. My goal was to modify material number 1. So to modify something, you have to assign the index number of the object and then you can modify it as you wish. So if I run the export now, I will modify index number 1, and it will, modify the information. So let's do it again. I run the export, and you should see now that it switches. Is it already done? Wait, now I have it's already 275. Did I already do it? Now I got a call and was a bit distracted. So let's do it again, 235, let's say, just to see it. So I want to change this from S275 to 235. I run it again, and you can see the change. Yeah. All right. So you can also modify objects if you assign the index number to the object. Use this add functionality, and then modify the structure. This also works with all the components. Yeah, I showed it only for the materials now because it's quite easy to show it with that, but you can use it everywhere. And I will show it again in chapter number 4. All right, so far regarding chapter 2. Let's switch to chapter number 3 of today's presentation. I want to show you how you can import data from RFEM into Grasshopper. Therefore, I will open a different file, importing into Grasshopper, and this file has various algorithms inside, alternative algorithms, which I will explain in the next minutes. To show the input, I will use a different file, and this should be this one. By the way, all the files can be downloaded. So the things that you see here, we add to the webinar. All right, what do we have here? We have here a mixed structure, a small concrete building, small steel structure behind that. The concrete building has some openings inside. Yeah, all right. Now, how could we import these information into Grasshopper? It's actually quite easy. Instead of using the RFEM6 export component, we have also an RFEM6 import component, which is this one here. You can run the input simply by using this Boolean toggle. Yeah, you can set it to true, and it will read the data into Grasshopper. Let's do it. I will run the import. And it's done. I will leave it as true, otherwise my information will be lost again. So I leave it on. And now you can see what we imported. We imported the RFEM data, and this is an RFEM data package. You can't do anything with this right now. Yeah, you have to split it up into each object. Yeah, and this can be done by using the RFEM data component, which is this one here. So you can connect the RFEM data with the RFEM data component, and this component will split it up into materials, sections, thickness, so basically all the objects. Again, if you analyze the output of those components, it's again, let's say, a cryptic object package which you cannot read directly, so you have to split it up again. And splitting it up again can be done by using the regular section component, for nodes, the node component, and so on. And you can do it by simply using the regular component that you have here in the list, and you can switch it from assemble to extract. Yeah, so you get the section package, section data package, and it will be split up into all the properties of the section. This is what I did here. All the section, node, line, and surface components have the option extract here. And you can also see what happens. You can now read the information from that package, the name of the sections that we used in this project. For example, also the area of the sections in SI units, of course, square meters. Regarding the node component, you get real Grasshopper nodes out of it. From the line component, you get the Grasshopper lines. And from the surface component, you get the Grasshopper surfaces. So this also results in this picture here, or in this graphic. This is what we import now. Yeah, you know, Rhino serves as a viewer for Grasshopper information. And this is what we imported. The surfaces and the lines and the nodes, including the openings. What we cannot do, this might be a question, we still can't render the beam cross sections in the, let's say, analytical model. Yeah, this is a feature that we want to implement in future still. Okay, oops, wrong side. So far so clear. I think it's straightforward. Import component, split it up in the data component, and then depending on which object you want to analyze, use the extract function and you get the information that you want. All right. How else can we modify the import? Again, I have a regular import component here, but this time I only want to import specific objects. I don't want to import all the information. This might take a long time in case of bigger structures. And if you only need, for example, the nodes or the lines, then you can use a Boolean toggle, set it to true, and say, just give me nodes and lines. Let's do it quickly. I run the import. I split the data package up again. And I used here now, of course, the nodes and the lines. And you can see the result. You get the Grasshopper nodes. We get the Grasshopper lines. But we do not get the sections. Yeah, it's a red line, orange line, because I did not import it. Yeah, so quite clear, I think, what happens here. We can also import only so this is a rough filtering of the objects that we want to import. Yeah, we can either say nodes yes or no, lines yes or no. But let's say you only want to import specific nodes and specific lines. Then we also have an option for that. And for that, we have the so-called filter component. Yeah, this filter component has a general look, but you can also use a specific subtype of this filter component for nodes, lines, and surfaces. Then it will have additional options. And you can define in this filter what you want to import. For example, for the nodes, I want to import all the nodes with an x coordinate between 2 and 6 meter and a z coordinate between 11 and 13 meter. And for this surface component, surface filter, I want to import only the quadrangular surfaces. Then you can connect the filter definition with the filter input of our regular RFEM import component. And then the usual workflow, splitting it up, extracting the data. Let's try it. All right. So we get now here 3 Grasshopper nodes. Again, the x coordinate should be between 2 and 6, and the z between 11 and 13, which is fulfilled for these nodes. We got 1 surface with the type quadrangular, can only be this one. And we can also double check it, of course, by having a look at the Rhino viewer, 3 nodes and the quadrangular surface. So this could be an option to, so the filters can be used to import only very specific data into Grasshopper. The filters can also be used differently, not before the import, they can also be used afterwards. This is what I show in this small algorithm. Again, regular import component, we split the data up via the RFEM data component. And before we extract now the information from all nodes, we use the filters afterwards, basically. So let's again quickly run the import. then we can also see the result directly. All right. So again, I'm extracting now, or I plan to extract the information from my nodes, but only from specific nodes. Here I have 100 imported nodes. With the filter, I filter most of them out. I only want the nodes within set coordinate between 11 and 13 meters. And this results in those 6 nodes. Yeah, basically the ones here on top. Same for surfaces. I can say I only want to import the surface index numbers between 3 and 8. And additionally, so this is an add, only surfaces with the geometry type plane. Surfaces with index number 3 to 8, well, we don't have 8, but never mind, we have 3 to 7. This would be all those surfaces now, but only geometry should be plane, so not the quadrangular surface. So these are the surfaces that I want to import. If you can quickly double check this, and you can see it here, the 6 nodes and the 4 surfaces. All right. So far regarding this, I think the import of objects from RFEM into Grasshopper is quite clear. You can use the Boolean toggle in general to control the amount of data, and the filters to really specify the information. Now, if you think of the chapter before where we modified an RFEM structure, we can combine both options now. We can combine the import from RFEM and the modification that we did before. So what I plan to do here is now in this last algorithm from this file, I want to parameterize the height of the upper level of the steel structures. Maybe not the most realistic example, but I think for showing the functionality, it's good enough. So what I plan to do is now I want to import these RFEM nodes from the upper level of the steel structure. I want to make the set coordinate of those nodes parametric, and then modify it and export it back to RFEM to modify my RFEM structure. How can I do it? Well, first of all, again, I have to import my RFEM data with the import component. I split it up. Let me maybe, before I extract the node information, I will filter the nodes out that I want to modify. So again, the nodes with the set coordinate between 11 and 13. And then I get the node package, which I can extract using the node extract functionality, and I get my Grasshopper nodes out of it. Now these Grasshopper nodes can then be deconstructed. I get the X, Y, and Z coordinates from those nodes, and I can create new Grasshopper nodes or points using the construct point component. I will link the X and Y coordinates, should be similar, but I want to vary the Z coordinate. And those new points or new nodes, they are the input for a new node component. This time assemble and not extract. So I will create new RFEM nodes using this parametric construct point component. And let's have a quick look how this looks. If we run the import first. All right, so we get the RFEM objects, the 6 nodes, we split them up into these 6 Grasshopper nodes. And then I have here these 6 new nodes where I can modify the coordinates. Let's say 11, for example. Okay, now if I want to modify the RFEM structure that I have here, I have to set the override to false. By default, it's false. So basically, you wouldn't have to do what I do now. I just want to show it that you are aware again of this feature. Override should be false because I don't want to override my nodes. I basically want to modify them. So this is clear. false. But if I would only have these new nodes from this component into my node component without the node numbers assigned to it, then I would simply create new nodes within set coordinate equal to 11. So theoretically, I would add new nodes with a set coordinate 11. So what I have to do to modify the existing nodes, I have to take the index number from these nodes that I imported and set them as input as the index number for the basically newly generated nodes. Yeah. So I want this, I simply link the index numbers from my import component or extract node component to my assemble component. Then I have a new export component, regular export component, yeah, as you saw it before, and I can run the export now. And you should see that these nodes will be modified. Yeah, you can see they are now on the, they now have the set coordinate 11. And now I can leave this on true and modify my structure or modify the set coordinates, and it will automatically update these coordinates. All right. I think the behavior is clear. You can import the objects that you want to modify via the import component, make this part of the object parametric or change it however you want, and then link the index number of the imported objects to the new objects and run the export having the override as false. This is the workflow to modify existing RFEM structures. All right, so far regarding chapter 4 already. And now I want to show you present the last chapter, the first steps of an automatic calculation loop using Galapagos. To do so, I will close this file here and I will open a new Grasshopper file. And let me briefly explain what I have here. I have here a simple truss, nothing specific. For the truss, I'm using the Lunchbox plugin in Grasshopper, yeah, where I simply have to define the dimensions of this truss, and then I get all the lines, yeah, the beams, the diagonals, and so on, yeah. And those lines I then connect to my member components down here, yeah. Before that, I will also create some sections and materials. So straightforward what we did in the chapter number 2. Yeah. I also define a couple of supports on the left bottom, on the right bottom side. And additionally, I create a load case and one load combination simply to have something that I can calculate afterwards. And then I send it to my export. So I will create this truss beam in RFEM, assigning a couple of sections to it. The next step that will happen is I will run the calculation in RFEM using this new calculate component. It's quite simple to use. It has a run input, so you can use a Boolean toggle to force the calculation to run it, yeah, or not. The name can be assigned, which I can modify, and you can assign the cases that you want to calculate. I left it out, so basically I will calculate all, but you could link your load combination, for example, into the cases to calculate, then only the load combinations will be calculated. Additionally, I have here this export result component, also new, as I said. This will export the results that you get in RFEM into a CSV or XML file. You can assign the name again. You have to assign the path to the folder where you want to export the results into. Yeah, simple path via string. And the type of the export can again be defined via a simple text box, basically CSV or XML. This is what you have to define here. All right. And the speciality on those components is that you can run it depending if the previous component was successful. So my first step is that I will export the data, model data, from Grasshopper to RFEM. If that was successful, it will give us here the information true. Yeah, it was successful, true. And with this information true, it will run the calculate component. Yeah, you don't have to do it manually. It can be done automatically. And if the calculation was successfully, we get again a true, and we can link it to the export component. And then it will export the results. So let's do it for now. This is all. And I will just change the name. File 2, maybe. Okay. And let's run the export. And not only the export, yeah, hopefully also the calculation and the export of the results. So RFEM creates a new file named file 2. It creates the truss here, and you can see it's generating the mesh, it's running the calculation, and now it should also export the results to a CSV file or to a couple of CSV files. All right, done. Let's have a look. I maximize RFEM for a second. We have here this load case and the load combination. You can see the results. Yeah, the deformation, for example, 0.4 millimeters. So far, so good. And let's quickly check the folder that I have here. I think it's on my desktop. Results 2. Yeah. So file 2 from just now. Yeah. And here you can see all the CSV files that we just exported. And for example, we can have a look at the combination 1 node global deformations. This is one of the result tables that I will deal with later on in this chapter. And you can see, okay, there's a header with the description. Then we have on the left the index number. And here, these are the results, yeah, with a maximum at 0.4 millimeters. Now, what is the next step? So far, so good. Yeah, we run the export, we run the calculation, we exported the results, but how can we make an automated loop out of it? Well, to do so, we would have to read the information from this CSV file into Grasshopper. And this is possible. Oh, I see I have to modify the name a bit because this is now the English presentation today and not the German one. So let me quickly modify this. .csv. Okay. And this is not the file 485, it's file 2. So it should work, yes. So what you can do is following. You can use this file path component from Grasshopper. And you can link the file path to it. And then there's another component in Grasshopper, read file. So this file, we will simply read all the information from this CSV file. I can quickly display it. Oops. And it looks quite similar to what we had in Excel now. Yeah, the header, the 2 lines with the header, then the index number on the left, and then all these result values. To use it properly in Grasshopper, I would need 1 value per line. So what I will do first is I will get rid of the first 2 lines. I don't care about them. Yeah, I don't care about the header. I know which value I want to use. So I'm using a split list component here, and I split the list with the index number 2. So I have now 1 list with the header, which I don't care about, and 1 list with all the remaining information from the CSV file. Now, as I said, I want to have all the values in 1 line and not multiple values in 1 line. So I can split the text. I can use this text split component. my trigger, let's say, is this semicolon, and then it will, see it here, it will give me for each line one value, which is already quite nice. The first value, however, is always the index number, which I don't care about. So I use a split list component where I get rid of the index number, and then the remaining list is this one here, where it shows me only real deformation, let's say, yeah, only the deformation values. And I want to pick one specific value from this list using the tree item component. I want to use from this branch number 12 the value numbers, the index number 0. Yeah, I want to grab this 0.4 millimeter as value, which is defined here, and this is then the value. And you can see it. All right. So this value I want to optimize. I want to basically optimize the deformation of my truss. And how can I do it? Well, this is where I used Galapagos as a first try, and I have to highlight first try because this whole workflow is, let's say, quite new for us because we just recently implemented the calculate and the export result component. So we are making steps into the direction of this automatic calculation loop. And my first try was using Galapagos, and Galapagos, let's say, works roughly in a way that you can define the value that should be optimized via the fitness. So you would link the fitness to this value, and the genome is then the parameters that you want to modify, or that you allow this component to modify. And I made it quite simple. Again, I have here this component. The fitness is this deformation value that I just extracted from my CSV file. And the variable that I allow this plugin to modify, in this case, is my height of the truss. Yeah. So the height of the truss is this number slider. This should be modified. And then we can run the let's say, automatic calculation loop. Let me quickly look. I want to minimize the fitness. Yeah, so basically minimize the deformation, and this plugin should search for the best result. I can run the solver, and one more information. It is required to leave this Boolean toggle here on at true. Yeah, we have to run it again and again and again, and this is what Galapagos will do. It will modify the height of the truss. That means the geometry will be modified. It will run the export again. It will hopefully be successful. It will run the calculation again, export the results again, and based on the new results, it will modify the input again, and so on and so on. So this is the loop that I created, and I can run the calculation now. I will just show it for a couple of seconds, or let's say maybe a minute, just to show you that it's working, hopefully here. So let's have a look what's happening. It should, in a couple of seconds, modify the height of the truss, and then run the export, the calculation, and so on. So right now it's calculating the structure again, exporting the results, and now it should do the first modification of the height. Let's see, yeah, there you go. This is the first thing that it will do, set the height to, I don't know, maybe 0.5 meter or so, and then do it again and again. I will wait one more cycle of it. Exporting results, and then modify the height again. Okay, yeah, I will stop it now. It will take a bit of time. What I did is I recorded it previously. Let me quickly show you. should be, sorry, this small video. Yeah, I did it. Yeah, I started the calculation. And then the same happens that we just noticed. It will create multiple variants, and the result, I did not finish the calculation, I just skipped it at some point. You get then the variance as an option on the bottom right, and you can click on this variant and say, please reinitiate this specific situation. So you can click on this variant where the result was 0.3 millimeters and say, give me the input data from this variant, and then you can call up exactly this situation in Grasshopper and basically also in RFEM. Or if you say, I want for some reason the structure where it was 0.5 millimeter, then you can click on this one, say initiate, and then you get the structure where it was 0.5 millimeter in the deformations. Yeah, so far regarding this chapter, again, it's also quite new for us. We try to find better examples for it. And of course, it only makes sense if you can relate it also to the design in RFEM. So what we have now is we can link it only to, let's say, analytical results, yeah, internal forces, deformations. It would be even better if we can link or if we can connect this automatic calculation to the design results of RFEM, yeah, steel design or timber design. But before we can do it, we have to extend our components a bit further. Yeah, we would have to, where's my Grasshopper? Never mind. We have to extend the member components with the information about steel design, yeah, equivalent member method, equivalent lengths, the general method. We would have to allow the input of timber related settings. And this is what we will do in future or the next weeks and months. And then I think this whole workflow makes even more sense. All right, so far regarding my presentation here, and I will hand it back to you, Andreas.
Okay, thank you, Lukas, for this presentation. Yeah, we got a lot of questions and yeah, we answered the attendees. Before I will show you where you can find the recording and the files, let me give you a hint. If you want to book a free online presentation, or you would like to get a non-binding offer for our programs or add-ons, just contact our sales team with that link here, or you can scan that QR code. You can download all the PowerPoint files from our website. Let me show where you can find it. Just a moment. On our website, dlubal.com, and under news and events, you can find the webinars. You can see the webinars that we present or will present in the future, and the also recorded webinars. That's today's webinar. In the next days, you will get an email with a direct link to that page here, and then you will find the recording here. Already now you can find the presentation slides and the Grasshopper files, and you will find the models below here. Okay, so that's also all from my side. Yeah, maybe a last hint: when you leave the webinar, there's a small survey. You can enter, for example, wishes for future webinars or what you liked in the webinar. You can leave it also empty, the fields, or just enter a sign. Just note, when you score the webinar, the worst score is 1 and the best score is 5. That would be very nice when you take the minute to fill out the form. Okay, then I have to say thank you for your attention. Thank you, Lukas, for the nice presentation. Thanks to Paul for the support by answering the questions of the attendees. I wish all a nice rest of the day. I hope we meet each other in a future webinar. Bye-bye.